Hey everyone, welcome to this episode of the Studio Storage Series. Today we're going to talk to Dell about Dell PowerScale, formerly known as Isilon, and their OneFS file system. Let's talk about it right now on A Cup of Joe. So hey, Greg Schiff from Dell here to talk about PowerScale OneFS, what was formerly called Isilon, still sort of is. I appreciate you coming on. This is part of the Cup of Joe storage series, where we're going through and looking at all the various storage options that there are for visual effects and animation studios today. And you can't do a series of this type without bringing in Dell PowerScales, what was formerly known as Isilon, right, which I will say for the record, I've personally deployed more Isilon, and even when I was on the studio side, worked alongside Isilon, probably more than a lot of the other storage systems. So I am a little biased towards it. I didn't want to state that right in the beginning, but needless to say, it's earned that bias because it's become and has been for a while one of the predominant storage solutions for the large visual effects and animation studios.
Well, it really, I mean, we are the granddaddy of VFX storage these days, and still are that way. I mean, something that you and I were chatting about a little bit before we started recording here was that, you know, the whole architecture of OneFS, Isilon, PowerScale, that product line, it fits really neatly in the requirements of M&E, right? Whereas you're scaling storage, you're scaling compute, you're scaling RAM, you're scaling connectivity, and it just goes right down the line of what M&E customers need, particularly when we're talking about visual effects, animation, rendering workflows. It just fits that requirement really nicely.
Well, you certainly know you are one of the premier solution architect. What is your current title currently at Dell? So I can.
I am senior principal solutions architect for media and entertainment, but I always take that a little silly because it implies that there's some junior principal architect running around somewhere, and that's not true. So I principal solutions architect, media and entertainment here at Dell Technologies.
That's great. And like I said, Dell is well entrenched in a lot of the studios. So you get exposed, I think, to a lot of the studios. Most, if not all, will remain nameless today. But needless to say, you've been involved with sizing up, solving for solutions for a lot of these studios. So I thought you'd be the best person to bring in to talk about how OneFS is different, what it does differently, how it helps the studios. And maybe you can talk a little bit about the history of OneFS, PowerScale, and how it came to be.
Sure, it's kind of interesting actually. So OneFS and PowerScale is it's ubiquitous across M&E, but obviously we are also somewhat ubiquitous in just regular enterprise storage workflows. But if you look at the history of OneFS, it comes from the media space. There was a guy here in Seattle, where I'm located, that was working for this company, Real Networks, back in the early 2000s, who was not happy with his options for media storage and said, hey, I can build something better and different. And that was the original OneFS Isilon product. So really the initial use case for this storage was media. It's not enterprise, I don't know, IT storage that we've shoehorned into media. It was built for media from the very beginning. So that's kind of interesting, and from that history way back in the early 2000s.
Yeah, and I mean, like you contrast it with the traditional IT requirements. As I'm always pointing out, the requirements in our particular little area with animation and VFX, most specifically, is the idea that there'll be thousands and thousands of hosts. These are render hosts, artist machines, all accessing the very same file. I often use the example of Thanos's ear texture. People might update that texture, and next thing you know, you've got hundreds of artists pointing at the texture, thousands of render machines pointing at the texture. And it's one great thing. One of the great things that OneFS does, right, is that it's able to generate many users that same file without any latency or really delay. Can you tell us a little bit how that works, or why OneFS is able to do that?
Yeah, absolutely. So OneFS is this clustered system, right? You add add storage nodes. Now, each of those nodes has some storage, compute, RAM, et cetera, et cetera. And there's multiple layers of caching within a node, right? So the node itself has an L1 cache, right, and RAM cache. And then there's an L2 cache that is global across the entire cluster. So as client connections come in, now the way NAS works for this is you might have, let's take a simple example where I have, say four nodes in my cluster and I have 8 client connections coming in. Now I might set that up so that each node takes 2 client connections in this very simple example, right? All those clients can access all the data all at the same time. And so if I'm talking to node, say node 1, but the file is in a RAM cache of node 4, that node can talk to that global cache across the cluster, right? And so then as you add nodes, I mean, this is a really small example I'm giving, you can end up with a very large L2 global RAM cache. So for your example with Thanos' ear texture, right, that gets changed. It's in L2 and now it's in RAM cache across the entire cluster, right? So everyone can access that at the speed of memory, which is going to be as fast as you possibly can get at that file. And that, you know, as we scale out and you have thousands of cores trying to access the same thing, you're never having to go back to disk. I'm not having to play games with copying things in and out of memory. It's just right there across the cluster. So that's one of our big differentiators. And they've spent, you know, tremendous amount of time in engineering cycles making that just super fast.
Yeah, and that cluster is quite scalable. You guys are able to ramp up and just add to the clusters and as needed in a way that is scale out architecture, right?
Right. So it automatically balances, right? As you add nodes, you can it will automatically balance that data between the different nodes, and then you can also have different types of nodes, right? I can have all flash, I can have some hybrid spinning disk and flash or archive, and we seamlessly tier data back and forth. Something we won an Emmy for, actually, the HSM capability of that. And you know, I come from another storage company where we also had a tiering methodology, but at that other company, so the data tiers down to spinning disk, and then if you want to access it, well, it's got to copy back up to the primary tier before you can access that data. And that's not how things work in OneFS at all, right? Let's say that data is on the flash and it tiers down to spinning disk. Someone goes to access that file, it gets served up immediately from the spinning disk without having to tier it back up necessarily. Now you could have a policy that says, hey, once this thing's accessed, give them the data and then tier it back up so it's back on flash if that's what you want, but it's not necessary for that system. So it's pretty slick.
Yeah, I mean, that's
works.
Pretty common, right, amongst the medium and large companies is to actually have some tiering set up where you don't want to have it's, of course, the artist and the supervisor would love to have all of the data on the fastest disk all the time, but as we know, that's not always so cost effective or even possible. And so often what you're doing with Isilon, right, is you're creating these tiers of disk that are essentially high performance at the more premium level, and then you'll have disk that's still performant but not to the degree that flash is, right? And explain maybe the tiering just a little more.
Right. So you exactly that, right? I might have a set of nodes that are all flash, and I have a set of nodes that are all spinning disk. I set up policies that say, hey, if it's a particular file type, or if it lands in a particular directory, or if it hasn't been touched in 6 months or whatever, move that data down to the spinning disk and clear up the space in the all flash. Then when client systems go to access that data, it's going to access it immediately. And I might have a policy that says tier it up, or I might not. And actually, an interesting thing with this, this has been an architecture that has become popular with some of my customers in the past couple of years now that we've introduced these small all flash nodes is a thing we affectionately call the mullet, right? So, and for this kind of setup, you'll have, say, a small pool of highly performant all flash nodes, and then you'll have a large, say, archive nodes on the back. Now, all the client connections are going to hit those all flash nodes. And so, but the data might not live on those nodes. So the part of the way that you're gaining cost reduction on the archive nodes, right, is that they're big, dense spinning disk. And they also tend to have lower performing CPUs and less RAM, right? So with OneFS, what I can do is the client connections hit the performant all flash nodes, which also provide the front end protocol. We're getting a little geeky here. So all the file sharing stuff that you need to like serve out SMB or NFS or what have you. And then there's a private backend network where it reaches and it's serving up that data through the flash nodes. The data never lands on the flash. It's all living on the archive. But what you're doing there is you're actually freeing up those archive nodes to just serve out data. They're not having to handle front-end protocol traffic. And so you're essentially using those flash nodes as accelerators for your archive nodes. And we've seen some pretty impressive performance numbers doing it that way, so that you basically the whole cluster gets faster, right? So that's one of the kind of nifty things that you can do architecturally in OneFS when you kind of dig under the covers and look at what's possible there. So
Yeah, I mean, you touched on the idea that there's a front end and the back end network. I think that's one of the unique propositions that the Isilon and PowerScale now has built into it here, is that a lot of the storage options out there will just put everything on one, basically one plane, one network. And the fact that you've separated the back end traffic and the front end traffic means that you can allow all this, magic to happen behind the scenes with PowerScale and OneFS, moving data in between, putting it into the right place, tiering it without saturating or even impacting the front end access of the end user or the render node, where it can be very sensitive to big data moves. So all that can happen sort of in the back end. And so that separation of traffic between the front and the back end, or the back of the house and the front of the house, is really, I think, gives the sysadmin and the system engineer some advantage. It gives them more lanes to work with and to really shape the solution that they want to see.
Yeah, no, for sure. And it would be worth noting that backend network is a totally private network managed by OneFS, PowerScale. It's not like you have to manage two networks there. We totally manage that and the switches, and that's all part of the system. And then you're just managing that front end traffic.
Yeah, you plug it in, and then the OneFS just takes over the management of that entire backend network. So, but it's a great and very robust parallel connectivity setup between all those nodes, though. That's where it really pays off. You're basically bonding them into one big machine by doing all of that.
Yeah, it really is, right? You get this one giant storage cluster with a whole bunch of CPU, a whole bunch of RAM, and a whole bunch of storage potential behind it, right?
Effectively a supercomputer for your storage.
That's right.
Using the classic supercomputer model, right?
Embarrassingly parallel, right? Yes.
One thing I like to talk about through all these is compare what I see are traditional size delineations between studios. We find our clients falling into these categories and often growing through these size categories. So we have smaller studios that maybe have 50 to 150 artists. They've got a couple projects going on. They've got maybe 4,000 cores and 100 render servers, maybe 80 to 150 terabytes of storage needs, of performance storage needs. And then you've got your medium tier, which there's a lot of these folks, these 250 to 400 people per site, 2 to 4 projects, 1,000 render nodes, 50,000 cores, starting to get up there into the 250 to 750 terabyte range. And then finally, there's the big players, right? The large studios that are getting up to maybe 1,000 people, 5+ projects. 200,000 cores is a number you hear a lot these days, 3,000 render servers, well over a petabyte of performance storage. At that point, usually tiered, right? Very few people have a petabyte on a single type of storage. That's a lot it's just a lot to happen.
That becomes a religious argument about whether or not that's even a good idea. So yeah.
Yeah, very, very true. So you've got these 3 tiers, which you could discuss as individual tiers. Some studios stay in their spot, but really what we're often trying to do is structure them for growth. We expect today's small studio to be tomorrow's medium, today's medium studio to grow into large. As we saw through the pandemic, many studios went from medium to large in the last 2 years. So as you're sizing up solutions for these kind of tiers, how do you go about thinking about it, or how would you do the same thing for small and large, or differently for small and large? How do you wrap your head around that problem?
Well, I think now would be a good to begin. Let's talk about the different node types that are available, particularly the newer PowerScale nodes that were released about a year and a half ago, 2 years ago now, but it's still fairly new.
Perfect.
So we had, we'll start with the new nodes, right? So these are the PowerScale nodes. They're all flash. There's 3 flavors of them. There's the entry level F200, which punches well above its weight class. It's pretty awesome. We have the F600, which is the mid-range flash, and then the F900, which is sort of the big dog. Now, these Isilon nodes are based on Dell PowerEdge servers, so they're 1 or 2 servers, depending on the node type. And this is the new, we call it Gen 6.5 Isilon, right? This is the new PowerScale stuff. We still have the a little bit older Gen 6 Isilon. It's all PowerScale now, but the Isilon nodes, and in fact, those have just been updated with the thing we call the midlife kicker. So these have recently been updated, and those are hybrid nodes, right? So we have they have a spinning disk and a little bit of flash, and we can talk maybe later about what that flash is used for, but. So for that, we have the H700, which is the workhorse node type. And this was the evolution of the H500, which I think a lot of the studios, particularly in Vancouver, are very familiar with. So there's the H700, the H7000, which is another workhorse style node, but is more dense. And now we have some archive nodes as well, the A300 and the A3000, right? So that's what we're looking at. We have your flash, hybrid, and archive. Now, what's exciting to me about the flash nodes is that we had an all flash product before, which was the F800, but it was pretty pricey and it was maybe a little bit overbuilt even for a lot of M&E shops. And we were kind of gapped in the small footprint all flash, right? We didn't really have a product for that. And that's really where the F200 came in and just knocked it out of the park. So if we talk about that really small shop, would you say your smallest size there was?
Like 50 to 100 artists, maybe 80 to 150 terabytes.
Right. So that's where an all flash cluster based on F200 or maybe F600 makes a lot of sense, right? It's performance for days. They're future proofed as far as that goes, and it's got a nice footprint and an attractive price point and all of that, right? That's usually where we like to lead off for that kind of workflow. Then when you look at that next tier where they're going to need more storage, maybe it's not cost, maybe they can't do it at all flash, right? It's just not, the cost isn't there. That's where we would look at the H700 node type, right? And this is a hybrid node. So it's primarily spinning disk, and then you have a bit of flash on there as well. Now, in M&E workflows, I tend to recommend that flash layer on those hybrid nodes. You actually use it for file system metadata only, right? So we're not doing tiering to that flash. What we're doing is we're saying all that little transactional B-tree file system metadata stuff, slap that on your flash so that your big spinning disks can do what they do well, which is serve up data, right? So that tends to be how we recommend it to set those up in M&E shops, though there's other options, but I always like to throw that out. So for that mid-range, that H700 might be a good fit. And if we talk about someone going from the small to the mid, well, hey man, they started out with a bunch of all flash and they can still use that. We talked about tiering before. There's all kinds of exciting, cool things they can do to combine those in a single cluster, right? One namespace. Then when we go to that next tier where they're starting to get really big, and the storage needs are continue to get bigger, that's where something like the H7000 might come into play, right? It has the same level of compute and RAM as your H700 nodes, but it's more dense in terms of disk, so it's going to take up less footprint. They are deep racks, and there's just a ton of performance with that as well, right? And then actually, I think you only mentioned 3, but we're going to go next to even the big multi-petabyte giant shops. And that's where we start to put in archive nodes. And that's where that mullet architecture I talked about before starts to become really interesting, where we have maybe a large archive that isn't really on the network, right? It's just talking to the backend network, serving up data, and all the traffic might be going through higher performing all flash nodes or something else that is serving up that front end traffic. And that's kind of how I scale that stuff out.
Yeah, and I can speak from on the production side from experience how you can grow into those archive nodes, which is more cost effective, is a direct function of how well you're able to manage your data within the studio, right? The constraint to people using archive nodes is not the technology. In other words, I find people have a hard time sometimes archiving data because within the production they're not sure what they can archive. This is a people problem. This is a production problem. It's a problem that Dell can help you solve, but they can't solve it for you, right? You need to decide how to archive that data. And when you do, the more disciplined your approach, the more you can be well planned about your show structure, well planned about how you archive portions of a show when it's no longer active, the better you can take advantage of this archive disk. So this is where that savings really comes in for studios, is when they
So
can.
I want to touch actually on a paper that I published a little while ago. We can maybe I'll send you a link later. You can do this, which was a metadata-based approach for tiering. And with that paper, I showed how you could take a tool like Shotgun and take shot status within Shotgun, pull that metadata down, and actually essentially use that metadata to drive tiering within OneFS, right? So that you can actually have that where, hey, if you mark something done in, say, a tool like Shotgun, or really anything with an API, you can have that filter down as metadata within the OneFS file system and use that to drive your tiering methodology. So there's some
That's
cool
been an
stuff with that.
often it's been a capability that's actually been underutilized and out there for a while. And I was really glad to see. I remember when, I think actually if you look in, I'll link to it here. If you look back, I think I did a short video when you released it through GitHub, this very feature. And it's really, it was nice to see that metadata capabilities were getting utilized, because we need to tie in the asset management database, the production database, and the actual storage system a little more tightly than it is in many circumstances, where it's effectively a combination of Excel files and screenshots where people are kind of trying to figure out where data is. And so if you can start tagging it both inside the operating system and inside your production management systems, it brings the two together, and now you can go find your data. And furthermore, you look to what Dell's brought in with Data IQ, being able to then also have even more visibility on where is the data. And once you know where the data is, you can then make very wise decisions on how to organize it, create policies to tier it. Yeah.
No, nifty stuff. It was fun to do that. It's an idea that a mutual friend of ours, Mr. Chris Kostiak, has been championing for a long time. He and I go back through many lives, so it's something he and I have been talking about for a long time. So it was cool.
Absolutely. When I came on board too, I was right. When I came on board with Chris a few years back, I was right on track with that, since I had already knew about this metadata capability within OneFS. It just wasn't being utilized. So when I heard you were doing it, I got quite excited about it.
Yeah, no, that's cool.
Man, getting visibility, the studios getting visibility on where their data is the key to managing it. And be honest, when you have a petabyte of storage, it's actually quite a challenge for an artist or a producer to know where all the data is. We're talking millions and millions, if not hundreds of millions of files. So these tools that, whether it's using the Shotgun API that you've helped create and gotten and published out there, or whether or not they're using Data IQ or even some of their own tools to tie in, it's really important that they start applying intelligence, business intelligence, to where that data is. And that way you can take better advantage of things like archiving and tiering, because if you don't know where your data is, well, you got a problem.
It's necessary, right? I mean, it's the old story that we've been talking about since we got into this business of, well, data rates are going up, they're going up, they're going up. I mean, I've been saying that for 15 years, right? It's not stopped. And so if budgets were endless, you could, hey, Dell's more than happy to keep selling you all flash nodes all day long, right? We can do that. But at a certain point, you need to be smart about what you're doing. Actually, that's another interesting thing. That's a new feature of PowerScale and the all flash nodes and those midlife kicker H700, H7000 nodes is inline deduplication and compression, which is now standard built in. There's no license for it. It's just a part of the system. And traditionally, for me, coming from media, I'm like, compression, dedupe, like turn that stuff off, right? We're already dealing with compressed files. You're not going to get anything out of it. But interestingly enough, some of our larger visual effects companies have actually left it on and been seeing some fairly decent dedupe and compression rates from the nodes. So that's another interesting thing with the new series of PowerScale, that actually we're kind of unexpectedly seeing some benefits for media customers.
Yeah, I
So
agree. I've
certainly something
seen
worth experimenting.
begrudging acceptance of deduplication as an efficiency, and to be honest, again, it comes down to the more your pipeline is tuned, the less it's going to help you because you're not creating as much redundancy. But in a lot of studios, with a lot of people coming and going, there ends up being redundant file usage all over the place. And where the pipeline tools can't catch it, these deduplication tools will effectively remove it, right, or remove the load.
So
So,
yeah, you could argue that it is a band-aid for a sloppy workflow, but all
well, there's
workflows are
always going to be
sloppy.
some duplication in
Yeah, right.
M&E. It would be nice if everyone knew every file was and there was only one version ever. But we just also know it doesn't work like that. We're
No,
dealing with humans, not robots here.
for now.
Good point.
One of the other interesting offerings that we've been doing is a thing called Apex Flex on Demand. This is a new Dell offering. Yeah, so what's interesting with this offering, particularly for PowerScale, is we're situating gear on the floor, right? So this is hardware living in your data center. And you set basically a term. So you're paying for it with OpEx as opposed to CapEx, right? So you're paying month over month.
And this is
And
operational expenses versus capital expenses for those who don't know about that. Basically, capital expense being very large sums of money paid up front or financed, and operational expenses paid on a monthly or consumable basis.
so the cool thing with this is there's a minimum commit that you're committing to for a term of a contract. So let's take an example. Let's say that you have you say, well, we're going to need a petabyte of storage over the next 4 years, but today I only need 500 terabytes. So what you can do with this is we will situate that petabyte of storage on the floor. You are committing to say 50% of that over, say, a 3-year term, right? So you're going to pay that minimum 50%, 500 terabytes throughout the term, but you've got the full performance and all the spindles behind you of that full petabyte, right? Because of the whole global cache and how all that works. And we talked about that earlier, right? Mm-hmm. And then let's say you go over it, right? At the end of the month, we look at the monthly average usage. And so we'll charge you if you say you go over to 600 terabytes, maybe briefly, and then back down. So you're going to pay for that, and then you're going to go back down to whatever your commit is. And then as you increase into that buffer space, you're still paying the same per terabyte rate of what was negotiated for the initial term. And then if, say, there's a new ceiling now, hey, we've gotten up, now we're at 2 years into this and we're using, I don't know, 800 terabytes now, we can revisit that contract, add more buffer, change that. The more terabytes you have and the longer you commit, the per terabyte cost goes down, right? So there's some pretty interesting things that we can do there for that. And what I like about it is that you're getting the benefit in that example of all of the performance and connectivity of the full petabyte, but you're only paying for half of it, right? And then as you grow into it, it scales with you. And particularly for M&E, where you might have a bursty period and then you go back down, you can handle that. You know what it's going to charge, what it's going to cost you, right? Because you know what that rate is, so it's predictable, and take it from there.
The load's going to come from concurrent sessions, right? It's going to come from how many machines and artists are pounding that storage server to serve up. So the idea that you've doubled the compute capacity effectively in that model you gave, while only using half of the actual storage capacity. Can you tell me a little bit about how is the PowerScale family looking to work with cloud options and cloud resources? That's always a concern for studios that are having to interact with cloud storage and such. Where is Dell positions itself in PowerScale?
Sure. So I can talk a little bit about what we're doing today, and then I think you can get an idea about where we might be going with this, right? I will say that today our cloud integrations are mostly cloud adjacent, right? So you're having a PowerScale cluster, a dedicated PowerScale cluster that is at a data center adjacent to the cloud that has sub-millisecond connectivity and tons of bandwidth to that cloud provider to access that data. You're not dealing with any kind of noisy neighbor shared infrastructure, right? That PowerScale is yours. So that kind of colo cloud adjacent model is one way of handling this. Another way of handling it is we have a multi-cloud system where essentially same idea, you have a dedicated PowerScale cluster that is in a cloud adjacent data center that has native access to all the three hyperscalers, right? Your AWS, your Azure, and your GCP simultaneously. There's a OneFS native GCP offering where you can actually manage the PowerScale from within GCP natively. That is dedicated hardware. And I will leave a teaser to say that in the hyperscalers, there is still a need for native performant multi-protocol file storage. AWS has a variety of solutions for that, but there's still a need for native cloud multi-protocol file storage, and so stay tuned. So pretty cool things there.
As we look at these large storage systems, support becomes a big part of the conversation. I think people should understand when they're buying very large NAS type systems, they're not just buying hardware, they're buying a support infrastructure. They're buying a service that's going to be attached to this device. And it's always important to keep that in mind. With the product without the service is really like driving a car without insurance. It's something you just don't want to do. So tell me a little bit about how Dell support works and what are some of the options available to people who decide they want to move into the PowerScale family.
Yeah, I mean, to be perfectly honest, I don't spend a whole lot of time with the support stuff, right? Because I'm a lot around the architectures of building these systems. But ahead of this interview, I did a little bit of digging, and there's a lot of options there, right? From we send you the part and you're going to replace it yourself, to having us send people on site to do that for you, to proactive monitoring where it can dial home and let us know what's going on. So it really just sort of depends on what the customer needs and what that level of comfort is. Some customers want a Dell badged person to come and do that work. Many in the M&E business aren't going to have some Dell badged person come anywhere near their system, right? They're like,
or aren't even allowed to with MPA restrictions, right? They can't allow. Of course, it's something that affects support, right? They can't necessarily have, as I said, Dell support will allow there's certain remote options, right, where you can actually remotely monitor a PowerScale device, for instance. But on a lot of our M&E, our clients, they're under very strict Motion Picture Association security guidelines, and they can't allow vendors to have direct access across the internet to those devices. So yeah, that can sometimes limit the support, make it a little harder. But anytime you want to send a log onto Dell support, there's no reason you can't do it, even if you're air gapped. It's just something you export and send versus Dell just reaching in and pulling out, right? That's the only real difference between those.
Exactly. So it's a balancing act between what level of security that is required versus having us monitor it. Now, to be honest, if we're monitoring it externally through the internet, it doesn't put any of your actual data at risk because they don't have access to any of that. But I know the MPA may disagree with me, and the TPN auditors might disagree with me as well. So we're not going to fight City Hall on that one. But it is what it is. Certainly, in my days when I was a sysadmin myself in New York, I wouldn't have let any badged person come in and touch any of my systems at all because it was my neck on the line. So
yeah, and for
so there's that, right?
Yeah, and for our medium and large size clients, to be honest, their teams are pretty darn sophisticated, and they'll give any old Dell tech a good run for their money on how to operate when they've been in deep in the trenches, actually churning and burning petabytes a year, getting shows out the door. They actually end up being the most fully informed support person is actually the admin who's working on themselves.
And they know the workflow. They may have been involved in designing the pipeline. They know what's going on there, and so we're going to partner with them. We can look at those logs, help them tease out what's going on. We have a whole group of guys that internally are known as the performance knights that can get involved with weird performance things and esoteric tunings and all kinds of nifty stuff that isn't obvious to even a seasoned OneFS administrator. So we have that kind of deep bench when it's required. I mean, the nice thing with OneFS is it usually just works out of the box, and without any of those esoteric tunings, but they are available, right?
our visual effects clients they're working on the bleeding edge, so they will often create loads that were just not ever foreseen by the engineers. That's just true all the time. If you're going to make new technology and new things work that have never been done before, you're going to end up doing things to your storage and to your compute, to your desktops, that have just never been done before. And so I've been in some of those calls. What's been great, when you basically, Dell is large enough and sophisticated enough that there's generally always someone who knows even more and is smarter who can be brought into a call to get that problem taken care of. And I've gotten to the point where there'll be times where even people who've worked on designing the various things that you're working on can be brought into a call to really sort through the hows and the whys. And it's really great. Those get to be very intellectually stimulating calls when you get those folks in and you start diving into how it works and why it's doing what it's doing. And the wows, they'll look to the client and say, wow, you guys are doing that with it. That's something that no one thought about doing before. And it's really great to see that push and pull. They become
that's one of the things I really enjoy about working in media, technology for media in general, is that we do the weird stuff first here, and then it flows into the rest of the world, right? There's so many examples of that where it was really the media industry pushing the boundaries there.
I think before AI and ML came along, it was absolutely leading the charge for the most performance disk out there required. Now we're out there paired up with HPC, right? So at my company, CW, our HPC teams and our M&E teams work together very closely, because what we're deploying is often similar, if not exactly the same physical solution, just matching up with a different need. But basically in the end, it's all the same. It's more files than you could ever imagine being served up to more hosts than you could ever imagine at a speed that you could have never imagined. And it's really fun to be around such high performance requirements.
For sure.
Looking forward, I know that there's been more focus on Flash with the PowerScale family lately. With what you can do outside of an NDA, is there anything you can tell us about what to expect from PowerScale family coming up in the future?
Outside of NDA, I would say that the software defined side of OneFS is going to continue to mature and expand, and there's all kinds of cool things on the horizon there. I would say that taking advantage of the full performance of the Dell PowerEdge server platform that the new node types are on, there's runway there. So there's some pretty cool things coming from that perspective. Another big focus that we've had is data orchestration, and how within, let's say I have a distributed OneFS environment, right, with multiple locations and different we'll just leave it at that, multiple locations, and I need to be able to move data around between those in various ways. Today we have Sync IQ, and there's a new version of that Smart Sync, and we're going to continue to make that more sophisticated and how it orchestrates data around a distributed environment. So those are kind of the things, the highlights of what's coming down the road for us.
That makes sense. The geolocation of data amongst studios and other companies that are located in 3 or 4 cities, but working on very large data sets nearly at the same time, is become one of the biggest problems to solve in storage. And I know we see it a lot in our multimedia, media and entertainment world, right?
Well, and there's a lot of vendors that are like coming in to fill that void of how to handle it. But and they all kind of skin that cat, to use that analogy a little bit differently. Mm-hmm. And for me, where they have to go in and out through gateways and obfuscate data and do all those kinds of things, I find most customers don't want to do that. They'd much rather deal with files and objects in their native paradigm and go from there, right? So
I'm happy to put people in touch with you and Dell if they want to reach out to me. Really appreciate all your time, and I can't wait to talk to you and say hi at SIGGRAPH.
All right, cheers. Thank you, Joe. Great to talk to you. We'll see you in a few weeks. Bye-bye.
Cheers.